Have you ever wondered why certain foods are staples in some regions, while others are impossible to grow there, creating distinct agricultural landscapes across the globe? It is a fascinating puzzle that reveals the intricate dance between nature and our food supply. Climate factors fundamentally influence crop patterns by determining which plant species can thrive in a particular geographic area, directly impacting global food production and agricultural economies. The availability of suitable growing conditions, dictated by climate, is the primary driver behind where specific crops are cultivated. The core mechanism behind this influence lies in a plant's specific physiological requirements for growth, development, and reproduction, which are intimately tied to local climatic conditions. Temperature is paramount, as every crop has an optimal range for photosynthesis, flowering, and fruiting. Too hot or too cold, and plant metabolic processes can slow or cease, leading to stunted growth or crop failure. For instance, tropical crops like coffee and bananas demand consistently warm temperatures, while temperate crops such as wheat and potatoes requiring cooler periods and distinct seasons. Precipitation, the amount of rainfall, snow, or hail an area receives, is equally critical for crop survival. Water is essential for nutrient uptake and plant hydration, with different crops having vastly varying water requirements. Rice, for example, is a water-intensive crop typically grown in floodplains or irrigated paddies, whereas drought-resistant crops like sorghum can thrive in arid and semi-arid regions with limited rainfall. The timing and distribution of precipitation throughout the growing season are also vital, influencing planting schedules and yield. Sunlight or solar radiation provides the energy for photosynthesis, the process by which plants convert light into energy. The duration and intensity of sunlight affect plant growth rates and productivity. Some plants are long-day plants, needing extended periods of light, while others are short-day plants, requiring longer nights to flower. This photoperiodism, the physiological reaction of organisms to the length of day or night, helps explain why certain crops are restricted to specific latitudes or seasons. These factors combine to create distinct agroclimatic zones, areas defined by their climate that are suitable for particular types of agriculture. Farmers adapt to these conditions through practices like irrigation in dry areas, selecting crop varieties bred for specific temperature tolerances, or using greenhouses to extend growing seasons in colder climates. Understanding these zones helps optimize land use for maximum yield and sustainability, guiding decisions on what to plant and when. For instance, researchers utilize tools like growing degree days, a measure of heat accumulation over a period, to predict crop development stages. They also monitor chilling hours, the total amount of time a plant needs to spend at cool temperatures to break dormancy and flower, especially crucial for many fruit trees. These specialized metrics provide deeper insights into the precise thermal requirements of plants, helping agricultural scientists and farmers make informed decisions. Ultimately, recognizing how temperature, precipitation, and sunlight dictate plant growth allows us to comprehend the distribution of crops worldwide, anticipate the challenges of climate variability, and strategically plan for global food security. It highlights the profound connection between our environment and the sustenance that feeds billions.